Okay, let's check answer for question 11. We are given figure 4.6. Refer to figure 4.6. We have a long straight conductor, carry current 7 ampere. And we have a rectangular metal frame, Pqrs, whereby PS is 3 cm from wire X. The side PQ is 4 cm, side QR is 11 cm. And a current of 5 ampere is flow in the rectangular coil. Alright, so the conductor X and the rectangular coil are in the same plane. So question A, determine the magnetic force on the wire PS. So we want to find what is the force acting on wire PS. So class, refer to the diagram given, we can see that wire PS will form a pair of wire with wire X, whereby both of the parallel wire carry currents that flow in the same direction. So we understood for any wire carry current in the same direction, they are going to attract each other. So we have force PS here. So this is the force acting on wire PS. Okay, so we can calculate the force by using the equations we have. Force per unit length for two parallel wire carry currents is mu naught I1 I2 over 2 pi d. D is the separation between the two parallel wire. So we can use this equation to calculate the force for wire PS. So force of wire PS over length will be mu naught I1 I2 over 2 pi d. So in order to find the force of wire PS, we shift the L to another side, so we put in the value. Mu naught is the permeability constant, 4 pi to the power of negative 7. Current I1, I assume, is the current that flow in wire X, 7 ampere. I2 is the current that flow in the wire PS, is 5 ampere. Then 2 pi, the separation between the two wires is 3 cm, change it to meters, 0.03. Then the L shift to the right, so we have multiplied with the length of the wire. So wire PS, the length is 11 cm, so we have 0.11. So let's do the calculation. So shift constant 33, call out the mu naught, multiplied with 7, multiplied with 5, multiplied with the length 0.11, divide by 2, divide by pi, divide by 0.03, so we get 2.57 to the power of negative 5. So our answer should be 2.57 to the power of negative 5 Newton. The direction is towards left. Why is towards left? Because these two wires is carry current in same direction, so wire PX will attract towards wire X. Alright, then we're done. Question A. Question B, the magnetic force on wire QR. So we want to calculate the magnetic force acting on wire QR. So we want to find FQR. What is the value of force acting on wire QR? Hence, calculate the resultant magnetic force on Pqrs and determine its direction. So we do the first part first. Okay, so we want to find FQR. So class, if you notice, wire QR also is parallel to wire X. So both wire X and wire QR, whereby the two parallel wire carry current in opposite direction, will have force between them. So what is the force acting between them? So since they carry current in opposite directions, so they are going to repel each other. So this is the force acting on wire QR, whereby wire QR will experience repulsive force from wire X because both of them carry current in opposite directions. Alright, so we can calculate the value of FQR using the same equation just now. So we are going to have mu naught I1 I2 over 2 pi d, so over the length, So we're still using the equation 38 in our list of equations. So force QR will be mu naught 4 pi to the power of -7. Current I1 wire X is 7 ampere. The current in QR is 5 ampere over 2 pi d. The separation between wire X and wire QR will be 3 plus 4, 7 centimeter. 7 centimeter is 0.07. Okay, then do not forget our L is shifted to the right, so we multiply with the length 11 cm, 0.11 meter. So let's do the calculations. So I get the force acting on wire QR is 1.1 to the power of -5 Newton, but the direction is towards right. Okay, then we can calculate the resultant force acting on wire PQRS. So we will notice that there are two forces acting on wire PQRS, which is force PS and also force QR. So they are both point in opposite directions. So we want to find the resultant magnetic force. PQRS will be force QR minus force PS. Why minus? Because both are pointing in the opposite direction. So we assume the force to the right as positive, the force pointing to the left as negative. That's why we have FQR minus FPS. So we have 1.1 to the power of -5 minus 2.57 to the power of -5 Newton. So let's do the calculations. So we will get -1.47 to the power of -5 Newton. So the negative will telling us that the directions of the forces, the resultant force. So the negative will indicates that the direction of the resultant magnetic force is towards left. Okay, towards left. So this is our answer for the resultant of magnetic force acting on PQRS.